Hey guys, George at SoundTraxx. Last week we did a quick installation on this Broadway Limited Berkshire Southern Pacific, and we showed you just a little quick glimpse into how easy it is to use the Blunami app to do all your setup and operations. So today we're going to show you just a little bit more of the setup and operation for this locomotive so that you can see just what you're missing if you go with anything other than Blunami. Let's get started. Now, as I've mentioned in the past, the Blunami is a full Tsunami 2 decoder. So you get, pun intended, all of the bells and whistles that you get with a Tsunami 2. All of the features, all the settings, everything that you get with a Tsunami 2. And the Blunami is a DCC decoder. And so therefore, if you have a DCC system, you can run it with your DCC system and you'll know no different. Where the Blunami really shines is the fact that you have the app that you can now connect to the decoder and run your train either through the app, or you can do all your settings, adjustments, and everything else through the app, and then just use your DCC system for operation. So today we're going to dive a little bit deeper into some of the settings that you might be maybe a little hesitant to try out, that we can show you just how easy it is with the app versus with the DCC system. So the first one I want to start off with is our dynamic digital exhaust. Now, dynamic digital exhaust is a feature that will read the load on the motor and then adjust the intensity and, in the case of a diesel engine, the notching based on the load that the decoder and the motor are actually encountering. So when you're running on flat level track, the engineer has no problem keeping the train at speed. But once you encounter a grade, now that engine load is going to get a lot heavier as your model is working to pull the cars uphill. Well, the engineer in the real world would have to apply more throttle or open the throttle up on a steam engine to get that train up the hill. Well, the dynamic exhaust simulates that. Now, the question is going to be, how does it do this? And the first thing is, basically, internally, the decoder has an internal graph that kind of is the expected use of or power consumption of the motor. And so inside, you may have a graph like this. Now, when the decoder needs the same amount of power, then nothing changes. But if the decoder needs more power, let's say we're running at speed step 20, and now the decoder is needing this much power, well, now that delta, the change in the expected versus the actual, the decoder uses that to now increase or show that the engine is now working harder to get that same train running, whether it's uphill, longer train, whatever the case is. Now, as you would expect, out of the box, the decoder has no idea what that motor power consumption is, especially if you just put it into an aftermarket model like this Broadway Limited engine here. So there's no way for the decoder to know that until we do a calibration. Now, the calibration, normally with a DCC system, we would have to go in and program some CVs while the locomotive is moving. So to do this, you would go in and set CV32 to a value of 2 so that we have access now to the 2 dot CVs. Then we would go in and set and start the locomotive moving at speed step 1. And then we would program CV503 to a value of 255. And then the decoder will then interrogate that motor circuit, see how much it's using, and plot a point on the graph. Now we get running at about our normal speed step 20, 30, 40, whatever you normally would run at speed. Then we do CV504 to a value of 255. And again, the decoder will interrogate the motor and check its power consumption and plot a second point on the graph. And then the decoder internally will create a straight line through that graph and says this is the expected power consumption. Now, of course, you'll want to do that on flat level track, light, without any locomotive or freight cars behind it, so that way we get a baseline power consumption of the motor when it's light. Now, the last thing is the sensitivity, and this is CV 2.512. So we're going to set 512 to a value between 0, which is off, or a value of 1 to 255 to determine how sensitive the decoder is going to be to changes in that load. And so the higher the number, the more exaggerated the change is going to be when you encounter that extra weight or load on the motor. I know I keep repeating load, but that's okay. It's important. But anyway, so the 2.512 then becomes your sensitivity to determine the adjustment and how sensitive the decoder is going to be. Now, to do that with a DCC system would take you a little bit of time because you have to go in and program each of the CVs, and then you're programming on the main line because your locomotive has to be running. And since you cannot run your train on your programming track, it makes it a little bit more challenging, and some people get nervous, and so they don't do it because they're afraid to program on their main line. Now go back and watch some of our other videos, such as Programming CVs webinar number 6. We'll talk about that in detail and show you why it's not a bad thing and nothing to be afraid of. But the good news is with the Blunami, the app does the hard work for you. So we're going to go ahead, and you can see my screen over here behind me. I'm going to go ahead and hit my gear setting, which is going to take me to the settings menu. Now we're going to go to down towards the bottom. You see DDE, Dynamic Digital Exhaust. Now you'll note that it says it's going to calibrate my dynamic exhaust for me. And it tells us what we need to do. We need to have a flat, clear track. So what I'm going to do is I'm actually going to pull this locomotive back a little bit because I've only got an 8-foot table. Now I'm going to go ahead and hit begin calibration, and the locomotive is going to start moving. You can hear it. It's moving at speed step 1. And there you go. Now the app has done the hard work for me. Now if you look at the screen here, you can see that it actually does set CV512. But we're going to go ahead and set this up ourselves. We're going to go to our CV settings, page 2. And we're going to scroll down here to the bottom, and you can see that our DDE load sensitivity is only a value of 32. Now, that's not a terrible thing. So we can start moving here at a speed step 3 or 4. But when I put some load in front of it, you don't hear as quite drastic of a change, and especially when I release. But now what we're going to do is, like I said, we're going to go ahead and set that sensitivity. Go to 512 here. I'm actually going to set this to a value of 125 so that it's a lot more drastic and a lot bigger change. So now, again, we're going to go speed step 4 or 5. You can already hear that chuff's a little lighter because it's light. But now when I put my hand on it, you can hear a much more drastic change in that chuff to see how the locomotive is working against my hand. Now the next thing we want to do is we want to add just a little bit of momentum. So we're going to go to speed settings, and up here we see that our acceleration and deceleration is 0, and that's for an instant start and stop. Now these are massive locomotives, and they take a lot of time and energy to get going to speed. Now we're not going to be too drastic right here. We're just going to go ahead and set a value of 75, which is actually about half of what I set my personal locomotives to. And then our deceleration, we're going to kind of do the same thing. We're going to set that to 150, which again is much lower than my personal locomotives, but this will give you a good idea of what it's doing. So what that does is it allows the dynamic processor time to do that dynamic digital exhaust changes to the sound while it's accelerating. If you're instantly jumping to speed step 10 or 15 or whatever, the dynamic processor doesn't have time to do that change, doesn't have time to make the changes to the sound. So it's there, but it happens so fast you don't really know it and appreciate it. So now I'm going to go ahead and accelerate my locomotive up quite a bit. Kind of hear that chuck bark a little bit as it's working hard. And then when I cut the throttle, you can hear it back off as it's coasting to a stop. And now you hear more of that rod clank. So you get a little bit more of those changes to hearing the dynamic exhaust work. And again, they start accelerating. When I really crank up the throttle, you can hear that locomotive barking as it's working to get up to speed. So this is just one aspect of being able to set up the decoder so that you get to enjoy running your train more so than fiddling around playing with buttons. Now remember, this will take effect also because the settings are stored in the decoder. So if I was to use my DCC system, all the settings are still the same. They're just stored in the decoder. So you're using the app to make all your adjustments and all your settings. So therefore, that's how you would set up the dynamic exhaust. Now, one of the other things we're going to do is we're going to go ahead and adjust volume settings, and we're just trying to make this video a little short, but I'm just showing you how easy it is. Now, when you're setting CVs using your DCC system, your volume settings are CV128, which is your master volume, and CV129 all the way up to CV160 are the individual sound effects. And without the list in front of you to look, you have to go look it up and figure it out. There's no real quick guesses. So, like, for example, we're hearing the injector right now. Let's say we wanted to change it. I don't have any idea what CV number it is, and I do this for a living. Okay, so now I'm going to hit my gear, and that's going to take us to settings. So we're going to go to sound settings, and then we're going to go, because the injector is considered an other sound, we're going to go to other sounds, and we're going to scroll through here until we find the injector. And there's my injector there. So you can see that it's set up with a volume of 65. Reverb is 0, which means there's no echo or reverb added in. Frequency determines how often you would hear it, is about 50%. Now there's a lot of these auto sounds, such as the safety valve, that will play randomly as the locomotive is used and sitting still. So the injector is one of those sounds, and it has a handful of those are the probability or frequency. That's how often you'll hear it when the locomotive is sitting. So those are just some different ones. We can see that it's a non-lifting injector. We can go to a lifting or a non-lifting. This particular locomotive would be a non-lifting, so we're going to go ahead and select that. But if we want to make our volume a little higher, we can use our slider bar and move this volume up and down, or we can simply type in a value, and you can see that it stays. Now that's setting the decoder again, because now we've adjusted our volume. So now that we've adjusted the volume on the injector, we can go in and turn it on, because it is also a manually adjusted sound. So I'm going to go ahead and hit function, and remember, we don't have to remember which function button does what. It's listed right there for us. So we just go through the list and we find injector, and you can see it's right there above the wheel slip. So we hit the button. And now you can hear the injectors a lot louder than it was before. And it'll run that long until we turn it off, and then it shuts down. Now, for those of you wondering, the injector is what takes the water in the boiler, mixes it with steam pressure, and pressurizes it, runs it through the pipe that then injects it into the boiler, usually at the coldest point in the boiler, so all the way up towards the front, so that way it gradually heats up, gets hot, turns into steam, goes into the steam dome, and then is sent down to the cylinders. So all access to all of our function, sound volumes, everything we want to do is right here in the app. You don't need to worry about changing CV numbers. Everything's right there. We can make all of our sound selections. So you can see that Blunami really does shine. And after all, like I said, Blunami really is a DCC decoder. And so therefore, you can use the app to do all your settings and adjustments and then run it with your DCC system. The only thing is that once you've connected to it from the app, you do have to take power away from the decoder, so that when it wakes it back up, don't connect to the app, run it with your DCC system, and then you'll be back in business using DCC. And now you can take advantage of all the cool features that Tsunami 2 and Blunami offer you through the really cool app of Blunami. So that's just a quick run through of some of the things that you can do with your Blunami decoder and how to get it set up, and showing you that you don't need to be afraid to try more than just the whistle and the bell. So guys, that's it for this week. Don't forget, be sure to get your SoundTraxx merchandise on our website at SoundTraxx.com. We got this really cool hat. Telling you, all the cool kids have this. And we got very, very limited numbers of these t-shirts, so make sure that you get your t-shirt and your hat today before they run out. Thanks for watching, guys. Be sure to like and subscribe to our channel so that you can be notified whenever there's more content like this comes out. And also be sure to check out our past videos. We've done a lot of updating on our playlist, so things should be a lot easier to find. Be sure to go in there and search SoundTraxx, and whatever topic you're looking for, chances are you'll find a video about it. So that's it for me. We've got to head out the door and get ready for Train Fest, so I'll see you guys next time.